electrostatic potential energy at any point due to charge q can be defined as the amount of work done by external agent to bring test charge from infinity to that point without acceleration. That means in the last expression we have find out with WAB, that is the work done from A to B here. Instead of A point is at infinity. So if it is infinity, so infinity from infinity to B point, if we take the test charge from infinity to B point, then the amount of work done is given by W infinity to B, and that is equal to the difference in potential energy between the point B and point which is at infinity, and the potential energy at infinity is considered to be 0. So U infinity is equal to 0, so UB minus 0, that is equal to UB. So we can easily find out in any point. It is the arbitrary point, it can be anywhere. So if we have to find out the potential energy at any point, then we have to calculate the amount of work done to bring the test charge from infinity to that particular point, and that is equal to, again you can see here that it is equal to this much, and it is equal to this here RA. This is your RA. So in the previous expression, if we put R infinity in place of RA, so it become like this, 1 upon R infinity minus 1 upon RB, and we all know that R infinity is equal to R infinity, that is equal to infinity, and that means 1 upon infinity is equal to 0. So this expression becomes 0, this one, and the only thing remaining here is minus 1 upon RB, which is, when minus is multiplied with the minus, it becomes positive, and final expression we can find out it is equal to this one. So the work done from infinity to that point is stored in the form of potential energy at that point, that is equal to KQ Q naught upon RB, or in a very general expression for this is K Q Q naught upon R, where R is the point, R is the distance of the point from the source charge. So it is just extension of the previous formula which we have already derived, and we have used this formula. In this formula we have put the value of RA. So if this one is infinity, so that the whole thing becomes 0, and the final expression is like this, which we have already find out over here. So this is the electrostatic potential energy at this point, and the next is the electrostatic potential. Now this is again very important note. It is let's see, in physics electric potential is not defined, but electric potential difference is defined. Again the same thing is over here, like in electric potential energy, the difference in electric potential energy is defined, not potential energy. In the same way, the difference in electric potential is defined in physics rather than only electric potential. So we have to keep this thing in mind while derive the electrostatic potential expression. So let's start. Electrostatic potential difference between 2 points A and B. First of all, we will find the electrostatic potential difference between the 2 points A and B, and then we can use this expression to find the electrostatic potential at any point. So let's start. with the definition, and the definition is electrostatic potential difference between 2 points A and B in electric field is defined as the work done in moving unit positive charge from point A to point B, from point A, this one, to point B. So work done in moving unit positive charge. See the difference between the definition of potential energy, electric potential energy, and electric potential. In electric potential energy, which is defined as the work done in moving test charge Q0 from point A to point B. But in case of electrostatic potential, it is the amount of work done in moving unit positive charge from point A to point B. So this is the difference. Here we have to take the test charge in case of electrostatic potential energy. We have to take the test charge Q0, and in case of electrostatic potential we have to take unit positive charge. This is the difference between these two. This is the difference in the definition. Otherwise both the definition are look like the same. The only difference is in potential energy we have to take test charge Q0, and in electrostatic potential we have to take the unit positive charge. So it can be also defined as potential difference between 2 point A and B as the electric potential energy difference per unit charge. As you can see here, the electric potential U is given by VB minus V, that is the potential difference, and that is equal to del U. Del U is basically it is the change in potential energy per unit charge. If we divide the test charge, then we can easily find out the difference in electrostatic potential energy per unit charge. This is not UB minus UA, this is UB minus UA divided by Q0. So this is the electrostatic potential energy per unit charge, and that should be equal to WAB upon Q0, where WAB is the work done to bring test charge Q0 from A to B. So in order to find the electrostatic potential between 2 point A and B, what we have to do, just keep Q0 over here and find the work done WAB, which we have already found out in the last topic. WAB, that is the work done in bringing the test charge Q0 from A to B, and if we divide that expression with Q0, then we can find out the electrostatic potential difference between these 2 points A and B. So once we know all these basic, then we can easily find out the electrostatic potential difference between these 2 points. So let's derive